While we're here at this particular point in the lab, I'll also talk about the pH meter, how it functions, and how we go about calibrating the pH meter. The pH meter is a device which will give us a numerical reading of the concentration of hydrogen ions that are in solution. How it goes about doing that is that the pH meter consists of an electrode which is located in the end of this probe. That electrode is a very thin layer of glass inside of which we have a solution. Hydrogen ions will pass through this electrode, and as they enter the solution around the electrode, they will allow for the conductance of a weak electrical current between the two ends of the electrodes in this pH meter. Based on the amount of electrical current that is being conducted, we get an indirect reading of the measurement of the concentration of hydrogen ions that are in solution. Right now, this electrode is being held in regular tap water to keep it moist. We always want to keep the electrode immersed in solution because if it dries out, it will destroy the integrity of the electrode. And the meter itself is simply a battery-operated, in this case, device. We see the pH readings here. This particular meter would read from a range of 2 up to a low of 2 up to a high of 12. And as we can see, the pH of this tap water at the present time is approximately 6. Now this pH of 6 on tap water, we would think water should have a pH close to neutral or approximately 7. But we need to realize this water is coming from a city water source, and because of chlorination of the water, that causes the pH to be somewhat lower than 7, in this case approximately 6. Calibration of pH meters is accomplished for both temperature. We set the temperature based upon the temperature of the solution which it's in, and we also have a standardization knob here which allows us to adjust for the pH reading. When I say adjust for the pH reading, prior to the time we start taking the readings, we are going to be utilizing a series of buffer solutions which are at a set or constant pH. Because we have a range of pHs here, we have solutions that run from 4 on this end to 7 to 10. And that's fairly standard for pH buffer solutions. I've already gone through and calibrated this pH meter to where when I had the electrode in the pH 4 buffer solution and 7 and 10, they read at these levels already. And so that's the purpose of the calibration knob or standardization knob on the pH meter, is to allow you to adjust pH when you know the concentration or the pH of solutions such as we do on these buffer solutions. So I've already gone through and calibrated with each of these buffer solutions to the appropriate pH level, adjusted for temperature, and then placed this electrode into the tap water, which is having a reading of a pH of 6. We're going to allow these two saturated paste extracts to stand and equilibrate for approximately 20 minutes. After that time, we'll come back and we'll take pH readings first on the distilled water solution, which will give us a level of active acidity in the soil, and then we will also measure the pH of the calcium chloride solution, which will give us at least an indication, if not an absolute quantitative measurement, of the level of reserve acidity in this particular soil. While we're waiting for this equilibration to occur, we're going to move to procedure B in this particular laboratory, which is determination or estimation at least of the cation exchange capacity of the same acidic clay loam soil. The second exercise in this lab deals with the determination of cation exchange capacity of a soil.